Assalamu alaikum. Hello, everyone. We continue our lectures. We are on the topic of basic clustering methods. So we reached here last time. So we're going to work with Python in building or creating the dendrogram as well as performing clustering. So we will load the data of this file, and we are going to create a data frame from the data of this file. So we have two features. We have a data frame. We have created a data frame of two columns. Then we are plotting the scatter plot, where x-axis is the feature A and y-axis is the feature B. So we're plotting A versus B, and we clearly see here visually that there are three clusters. Now we're going to create the dendrogram. So we import scipy.cluster.hierarchy as a SHC. Then we call the function dendrogram, and inside it we pass this as input arguments, which is the outcome of the calling the function linkage. We pass the data frame. The method here, we choose it to be complete. So that means in measuring the distance between a point and a cluster, or between two clusters, we rely on the maximum distance. Okay, so we measure for example, if we are measuring the distance between a point and a cluster, then we're going to take the distance between this point and every point in the cluster, and then we take the maximum of these as the distance between that point and the cluster. So if we pass complete, then we rely on the maximum distance. If we choose single for this input argument, the method, if we set it method equal to single, that means we rely on the minimum distance. So we use the minimum distance as the distance between a point and a cluster. So what do we mean by that? So we take the distance between that point and every point in the cluster, and then we take the minimum of those as the distance between that point and that cluster. And same applies if we have two clusters. So you take the distance between any 2 points, and the one with minimum distance. So the minimum distance, the minimum of all of these is the distance between these two clusters. As I said, there are more options. It's not only like maximum or minimum. There's also the average and some other choices. Okay, you can look at the documentation of this method, and you will find the documentation of this function, and you will find all other options and their explanation. So the metric we use here to measure the similarity is the Euclidean distance. Okay, so let's look at the dendrogram. Here is the dendrogram. Okay, so if we choose our threshold to be 10, then we have three clusters. Okay, this is one cluster, this is the second, and this is the third. If we choose our threshold to be 20, then we will have two clusters. So we are passing through two lines here. So this would be one cluster, and this would be the second cluster. Okay, so it depends on our choice of K. So here, looking at this, we can come up with a conclusion about the number of clusters. In fact, this is very simple example. Here we clearly see K equal to 3 is the best choice, maybe. Okay, so we can also go with K equal to 2. Then this will be one cluster, and this will be another cluster. And that's actually what we also see here from the dendrogram. If we choose the threshold to be somewhere here, then actually this cluster corresponds to this, and this cluster corresponds to these two together. Okay, so yeah, we can also look actually at the values of the values that different samples can take for feature A and B. These two columns represent feature A and B. Okay, so for example, when it's very bright, then the value is high for both. Okay, when it's dark, okay, then the value is low. So by looking at these colors, we can tell this represents which. Let's start from here. So for feature B, it's very dark, so the value is very low. It's below -10. And for A, it's also a little bit less darker, but it's in the dark side. So it's around maybe between -10 and -5, the value of A. Okay, then actually this corresponds to this cluster here, where the value of B goes, value of B goes as low as maybe minus 15, and the value of A goes as low maybe as minus 7, okay? So this corresponds to this cluster, okay? So this part here, this, okay? And these samples, these are the samples. Okay, this one here, so it's less darker in the middle, like around 0 for B, and it's at the bright side of A, very high for A. So it's actually this one here. This corresponds to this one. So for B, we are around 0. For A, we are like at the high side, okay? And the last one, both of them are bright. So both of the value for both are high, which is this one here. Okay, that's like a good visualization tool. Okay, so we call the function cluster map, okay, and we pass those input arguments, okay, the ones we explained in the previous cell. Okay, so there are three clusters. So somehow we run more than one visualization tool, and we came up with a conclusion that the number of clusters is 3. Then we perform the actual clustering here. Okay, so we call the function, so we import from scikit-learn.cluster, we import agglomerative clustering, okay, and then we call it agglomerative clustering, and we pass these input arguments, okay. So the number of clusters is equal to 3, and the linkage is equal to complete. So here we created the object, okay, for the uh, the clustering object, okay? And here we fit that in our data. So with this, like with this line, we created the object, and we actually trained it on our data, okay? So then we can like look at the scatter plot. We actually, what happens here, let me explain a few things before we look at the figure. So now we created the object, as I said, and we fit it in our data. So we have some returns, okay? So we actually return labels, okay? So we have this property here inside this object, labels underscore. So we are accessing these labels because once we clustered our data points, we actually added labels to them, okay? These belong to cluster 1, these belong to cluster 2, these belong to cluster 0. So how do we access these labels? By retrieving the value of this labels underscore. So then from those, we created a new column in our data frame, a new attribute, and that contains the labels, okay? Then we added that column to our existing data frame. So now our data frame is the old version plus adding this column that contains the labels. Okay, so we will have 3 columns, and we use we use the hue here, so to color like the different dots here and points based on the different choices of the labels. Okay, so we use the labels in order to define the colors, and since we have 3 clusters, we will have 3 labels. So we pass our own choices for the colors, calling the palette. And here we give a color red for the points that belong to the first cluster, color green to the points that belong to the second cluster, and color blue to the points that belong to the third cluster. So here, what we are doing, we are plotting the scatter plot of A versus B, and we differentiate. We use the labels to differentiate the colors of the different points we plot here. Okay, so then we look at them. So this is the green color. Okay, this is class 2 or cluster 2. It's colored green. Cluster 1 and cluster 1 is the green color 1. Cluster 2 is the blue, and cluster 0 is the red color cluster. Okay. So in conclusion, here we created the object for the object of the clustering object, and then we train it in our data, and then we plot the clusters again, but we just use we added the hue here, so we color like the points based on which cluster they belong to. Okay. Now we come to k-means clustering. It's a divisive type of clustering. So we begin with a decision on k, the number of clusters. So later on, we will show like actually what we do. Actually, we define different choices for k, and we do clustering based on that. And then there is a set of metrics we use to choose the most reasonable choice for k. Okay. So anyways, so k is defined. We start with the choice for k, and then we will iterate between two steps. Okay. Let me explain them here visually. What are these two steps? Okay. So let's run this video here. So these are our data points. We clearly see here visually that there are three clusters. Okay. So we will choose k equal to 3. Okay. And then what will happen, the first step after our choice for k, so we identify k. Okay. K is equal to 3. Then what happens after that, we will select initial centers. Okay. In the simplest version of k-means, these centers are chosen randomly, but there are more advanced versions of k-means where these centers are chosen in a systematic way, because our final outcome depends on our like in this initialization step. If I initialize the centers in a better way, I can achieve better clustering at the end. Okay. So here, let's assume we initialize them randomly. Okay, that's the first thing we do. So these centers are initialized randomly. Then what we do after that, these are the two steps we will iterate between, because k-means is an iterative algorithm. The first step is to measure the distance between every data point and every one of these centers or centroids of the different clusters. Okay, so we will measure the distance between every point and every one of these centers, and we will associate this point to the center that to the cluster that is defined by the center in which the distance is the minimum. Okay, so this point, let's refer to these clusters as cluster X, cluster Y, and cluster Z. So this point will have a closer distance to this center than these two centers. So this will be part of the cluster X. Okay, so by doing so, we will come up with the initial assignment. Okay. So these points will belong to cluster X. Okay. And let's look at the boundaries will be actually will be visually shown here. Okay. This is the initial assignment. So all of these points belong to cluster Y. These points belong to cluster X, and these points belong to cluster Z. Okay, so that's the first step. Okay, the second step, okay, is to take the mean of the points that belong to a specific cluster. So for this one, you take the mean of these points, and that will define the new center. The same thing here and here. We take the mean, and that will define a new center. So if you look into this cluster here, most of the data samples are here. So if we take the mean, then Y will move somewhere here. X will move somewhere here, and Z will move somewhere there. Let's look at that visually. Now, what happens to these points here? Now, we're going to go to the first step. As I said, we alternate between two steps. Okay, we go to the first step. We take the distance between every point and every one of these centers. Okay, so every point and every one of these three centers. So these points will have closer distance to Z than Y this time. Then what will happen? These points will be removed from cluster Y, and they will be added to cluster Z. Okay, so we keep iterating this way until either we converge, so there's no change anymore in the centers and the assignments of the points, or we reach the number, the total, the maximum number of iterations, because sometimes we do not converge. Okay, and the final outcome depends on our initializations. Okay, if we initialize the centers very well, then we can achieve good results. So that's why actually one way is to actually perform multiple initializations and then you at the end you choose the one that performs the best according to the metrics we use to define what is the best. Okay. In fact, maybe I don't want to go so much beyond the theoretical foundations of k-means, but k-means actually is minimizing some loss function, okay? And that actually loss function is difficult to minimize because it's not of a convex shape. There is no only one global minima. So it's some loss function, okay? So we are trying to find the solution that minimizes that. And then, so if I have, like, if I have tried different initializers and then at the end I can reach a value for the loss function, then the one that achieves the lowest value for that loss function among the initializers that I have chosen is the one that I will choose as the final outcome for my clustering algorithm. That's at very high level. I don't want to go into the details here. Okay. So now let's look at k-means using Python. So here we load the same data again. We have the two features A and B, the scatter plot again. These are the three different clusters as we saw previously in the previous example when we used the hierarchical clustering. So now we will from scikit-learn.cluster we import k-means. And then here we call k-means, we pass these arguments, okay? So the number of clusters is equal to 3. The maximum number of iterations is equal to 1,000. So we will iterate. The maximum number of iterations we can give is 1,000. So we don't yeah. So we stop after 1,000 iterations, okay? So the number of initialization is equal to 10. We will initialize the centers 10 times. For each one, we will come up with a choice for the clusters, and then we will choose the best. The initialization is random. N is equal to random. As I said, as we this is exactly what we did here. The initialization was random. Okay, there are other choices. For example, here there's k-means. It's a more advanced way of initialization. It's not random. Okay, so at very high level in k-means, what happens? So the goal here is to choose the centers as far apart as possible. So we randomly select the first center, but the probability of selecting the second center is proportional to the square of the distance between that center and the first center. So there is high probability to select the second center to be far away from the first center than being close to that, okay? And same for the third one. It has to be also the probability of selecting it is proportional, like the probability of selecting a point to be the center is proportional to the distance, the square of the maximum distance between this point and all and the first two selected centers. So with that, actually, better performance can be achieved compared to just random selection of the initialization, but also it comes at more computation cost here because you need to do some pre-processing before you run the k-means, okay? So that's about the initialization, okay? So the random state is equal to 0. Whenever there's randomness, if you want to reproduce the same results again, when you run the same cell, then you need to have a fixed seed for that. So that's it. So so we call k-means with these arguments. So we create the object, and here we train it on our data, and then we plot the scatter plot of A versus B, the same thing we did in the previous example. So here we just add X mark in the centers of the different clusters, okay? And these are the three clusters we came up with. If we set K and number of clusters equal to 2, we get something like this. So this is the center. This is one cluster, and this is the center of that cluster, and this is another cluster. Okay. So if I go, for example, K number of clusters equal to 6, then we start to see things that, okay, like this, okay? But of course, if we look later on, in fact, here, it's coming after. So there are metrics that evaluate our choice for K, and based on this metrics, actually, we can tell which choice of K is the most reasonable one. And that is something we're gonna come to next, inshallah. Okay. So maybe for today, we stop here. And as I said, next time we will talk about different metrics we use to evaluate our choice for K, or the number of clusters. Let's stop here and see you next time. Thanks for watching. Assalamu alaikum.